muscle is composed of skeletal muscle cells, also called muscle fibers. Fascicles are muscle fibers arranged into groups. Myofibrils are composed of protein subunits called myofilaments. The sarcoplasmic reticulum stores and releases calcium ions into the sarcoplasm after the muscle is stimulated. The sarcomere is a contractile unit of a myofibril. The M line supports proteins that hold the thick filaments together in the H zone. The H zone is a region where only thick filaments are present. The Z discs separate one sarcomere from another sarcomere. The Z discs also serve as anchors for thin filaments. Thick filaments contain the protein myosin. They contain projections called myosin heads. Myosin heads form cross bridges that link thick and thin filaments together during muscle contraction. Thin filaments contain the protein actin. They contain binding sites for myosin heads. Troponin sits on top of tropomyosin. Troponin is the binding site for calcium ions. When calcium ions bind to troponin, it changes shape, forcing tropomyosin away from the actin filaments. Calcium ions are released from the terminal cisternae and attached to the troponin binding sites. Binding of acetylcholine molecules to acetylcholine receptors at the neurotransmuscular junction opens chemically gated ion channels that allow sodium and potassium to pass. Because the driving force for sodium is greater than that for potassium, more sodium diffuses in than potassium diffuses out, causing depolarization. The sodium channels close and the voltage-gated potassium channels open. Since the potassium ion concentration is substantially higher inside the cell than in the extracellular fluid, potassium diffuses rapidly out of the muscle fiber, restoring negatively charged conditions inside. The action potential propagates along the sarcolemma and down the T-tubules. Transmission of the action potential along the T-tubules of the triads causes the voltage-sensitive tubule proteins to change shape. This shape change opens the calcium release channels in the terminal cisternae of the sarcoplasmic reticulum. Here are the steps of muscle contraction. Step 1. Calcium ions are released from the terminal cisternae into the sarcoplasm. Step 2. The calcium ions bind to troponin. Step 3. Tropomyosin shifts and exposes actin binding sites. Step 4. ATP allows the myosin head to form a crossbridge to actin. During the crossbridge cycle, ATP is hydrolyzed, and this energy cocks the myosin molecule at its hinge into an upright position. Then, actin binds to the myosin head, forming a crossbridge. This pulling motion is called the power stroke. The M line and H zone disappear. The power stroke. The myosin heads move the actin filaments closer together. Step 6. The myosin heads wait for ATP to arrive. Step 7. The myosin heads release from the binding sites. Step 8. Calcium returns to the sarcoplasmic reticulum. Step 9. Tropomyosin reshifts around the binding sites. Step 10. The sarcomere is in place for when another movement occurs. The sarcomere is at a resting state. This process will continue as long as calcium and ATP is available.